So we're 1 minute left to the talk. That we have we are very fortunate to have a guest from Germany, and he will be talking about the open source PDK, just like the person that write to me that he said this is very, very rare because it's almost a trade secret for the foundry. Yeah. So without further ado, let's welcome our friend Vater from IHP.
Okay, thank you very much. Welcome to my talk. It's a follow-up from my talk in last year. So I will give you a short update and what's the current status and maybe what we will even do in future. At first, I'd like to introduce the IHP itself because most of them won't know the IHP. We are Leibniz Institute. We are the research facility for high-performance microelectronics, and we are located in Germany. And we are research and innovation center for silicon-based systems and ultra-high-frequency circuits and technology. And that's even the reason because we have this BiCMOS technology. I will later even talk a little bit more about this technology itself. And we have a vertical research concept, so it means we have everything starting from material research to technology department, so means the fabrication of the devices in our clean room up to the system department, and on system level you can even create microcontrollers, high power processors, even some integrated stuff, maybe using MEMS-resistive devices for AI applications and so on. As you can see, we are more than 300 people which are working in IHP, and we get even additional support by students and so on, technical stuff, everything what you need to drive such a large institute with administrative, and even you can see the clean room that's on the picture on the left side. Yeah. And this is even our unique selling point. So we have a 200 millimeters pilot line for state-of-the-art BiCMOS technology. And this is even in industrial-like style. So we are running 24 hours, 20 days, 7 days a week to produce prototypes and even low-volume productions. Our technologies are qualified. So it means you can even build your devices, for example, for measurement equipment and so on, and we have a qualified technology, so it means everything what you get is reliable under certain conditions. Our clean room area is roughly 1,500 square meters, and we have the specific CG BiCMOS technology. And we have sorry. Something happens. Okay, coming back. Okay, I will not move anymore. What we even have, we have two different technologies. One is the quarter micron technology, mostly used for EPIC technologies, and the 130 nanometer technology, which is mostly used for RF applications. We have a type of circle. This circle shows you the dependencies between all the stuff that we have in which are related to the open source PDK, open tools, open designs. And you see a strong dependency between everything. Without the PDK, you cannot create the tools. Without them, you cannot even verify the designs and so on. And it's very hard to break the circle to start a type of development for everything. Yeah. For example, you cannot develop a tool if you don't have the input from a PDK. And the second is, if you don't have designs for checking the tools, it makes no sense to develop it further. Yeah. That's a little bit a complete overview about the challenges for the PDK development. So, as I said already, there's a strong dependency between the PDK, the tools, and the designs. So, how to start? Basically, the PDK is provided by the fab. And I can say that the PDK is more than a process specification file and the design rule manual. Since I'm in the team leader from the PDK team in IHP, I can tell you that it's much, much more. Yeah. And one simple example, the files that we are providing in the PDK, let it be a MOS simulation model, for example, that has to be compatible with the tools. Second example, if you have a standard cell library, it has to be well usable. It's not enough to provide a standard cell library that works somehow. If it's not efficient, no one will use it because your processor is getting very large and maybe not reaching the stuff that you like to get, yeah, for example, the frequency and so on. For the tools, how do you get the tools for the open source designing? At first, you have enthusiastic single person, yeah. For example, the ngspice, it's a simulator, it's originally from Holger Vogt, he developed this. Then you have research activities of PhD students, or you have funded projects. Yeah, everything knows different, for example, the open road stuff was even a large funded project. And yeah, even one challenge, who maintains this after a certain time. Yeah, some people left, the PhD students are ready, and so maybe the project in GitLab going to sleep. Yeah. And the last problem or challenge is are the designs. Just making a design makes no sense. You have it virtual, it makes no sense to have just take a look onto the pretty nice picture. If you have the layout and the schematic and so on, you will even get a real hardware. But finally the question is, who can pay the design? Maybe you know it's relatively expensive to get final silicon. Luckily, for example, with the Google Vater, there is a possibility to get free samples, but mostly you don't have the possibility to verify finally your design in silicon. What might be the solutions? At first, you have to have the idea of the open source PDK itself. That sounds very easy, but you need this as a starting point, the idea itself. Yeah, without that you cannot start. Yeah, then we were very lucky because we get some funding by a German ministry from BMWF. And finally, you need, of course, the people. Yeah, you need the ideas, you need enthusiastic workers, you need time for that, you need knowledge. Without the knowledge, you can be, it can be very frustrating finally, and you need even collaboration. Without collaboration with other people, other research institutes, you cannot do anything. Some words regarding the funding. We got the funding in FMD QNC project. It's in the last line mentioned, and there are three main tasks. The first one is developing PDK. The second one is tooling and teaching, and the last one is open design platform. I will talk about each point separately. And new point is, maybe you can see it in the third line, we are supporting the free the free area in our MPW shuttle runs. And finally, even we like to push our German Microelectronic Academy with certificated design courses and design infrastructure using our open source PDK and even the tools. Some words about the open source PDK itself. Maybe you know the slide already because I give it from time to time. At first there was a really internal discussion. It took a long time. Should we release an open source PDK? So finally we made the decision yes, and then was the second question, which technology? So now 2 years ago on the ASIC in Paris, we announced that we will release an open source PDK for our IHP SG13G2 technology. And in the next line you can see the technical details. So it's a by CMOS technology with an HBT of FT, Fmax of 350, 450 gigahertz, and CMOS part with 130 nanometer technology. The first technical data were published in March 23 on GitHub, and even there's a link. If you like to use the QR code, you will directly go to the website. And yesterday I checked, and we have more than 360 commits in total. What you can find on the GitHub project, just take a look. There's a Gantt chart for the how we like to proceed in the project. As I said, you need the process specification, the layout tool manual. Then we have a KLayout property and tech files, the different models for simulation, one side for HBTs and even for Spectre, for CMOS, and even some other stuff what you have in such a technology. Resistors, S-Ray caps, and so on. There's support for OpenEMS, so you can even have a type of EM simulation. We have the primitive devices, so the MOS transistors and the bipolar transistors, even as GDS, and later I will even explain how we can create a type of pi cells, and finally some MOS and HBT measurement data. That's even quite nice, because in that case you can verify. You can run a type of simulation, and you can verify this in the simulator against the measurement data. And you can take a look, okay, is the simulation right? Or is there maybe a bug either in the model or in the tool? Can be in both, yeah? Then we're offering a type of standard cell library. This is still in development, and this is even, I'd like to mention this, a quite nice example, because last year, I cannot remember exactly in which month, there was a hackathon, luckily at ETH Zurich, yeah, and they provided some additional cells during this hackathon for our technology. Quite nice example for collaboration. Then we have even SRAM cells. It means not cells that are complete SRAMs. Yeah, you can use it, for example, 180-bit are available, words with 8-bit are available as SRAM itself, and we have some test structures. Here's an example of the design flow, how we can see, or how you can do in an analog design. This is a type of basic approach. You can see on the right side which tools you need: XGEM, COOX-S, ngspice, XSpice for simulation, and finally KLayout for layouting, and OpenEMS for EM simulation. I do not want to go in detail later, because just recheck the slides if you are interested. Then we have a type of digital flow. Clearly, it based on the analog basic PDK. Without the analog basic PDK, you cannot develop the digital standard cells. We are providing a digital standard cell library, including I/O cells, and we have support for the open road and open lane apps. And with the help of that, you can generate digital layouts. Once in the circle you have seen, there was even one in the lower left corner, something about tooling, open tool development. Yeah, and what we are doing not in this project is we do not develop complex tools. That's not our approach. What we like to do, we like to enable type of basic flow, and this means we have to have some minor enhancement and bug fixes. Yeah, for example, in the ngspice, some bugs came up, and then we contacted Holger Vogt. You can see in one of the lines. Then there was even some collaboration in COOX-S with Mike Bryanson, and even KLayout. It's well known. We have direct contact to Matthias Köfferlein. This is quite nice. I will explain later why. And even OpenEMS, there is one guy from, his name is Jan Taro Svetja. The example for the KLayout that I'd like to give. We providing a KLayout oriented design flow, and you need parameterizable cells. So it means if you have a CMOS transistor, you like to scale it maybe in width or length or whatever. And finally, you need to have a type of physical verification. But main focus is currently on the cells itself. And you can see on the top, there's a rectangle and KLayout pi cells. And this is type of layout drawing, because we have an approach to generate this type of pi cells. Maybe one of you knows Synopsys Pi Cell Studio, and this has an API. And what we are doing in conjunction with help from Matthias Köfferlein, we are implementing this API from Synopsys Pi Cell Studio with KLayout. This has the advantage, if you have programmed a Pi cell, which can be run in Synopsys or can be used even in, I think ADS supports this, and one very old version of Cadence Virtuoso, then you can directly load the cell and change the properties even in KLayout. It's not required to adapt the Pi cell code. You can take exactly the same Pi cell code. And from my point of view, this is quite nice, because you have one single source and you can use it in different tools. Yeah. And clearly, so finally it maps to the technology itself. In our case, SG13G2 technology, but we even provide this stuff on GitHub later, so that you can even reuse this in your PDK. If you develop a PDK for your foundries, then you can take this one. Yeah. And so we started to develop some Pi cells. So currently we have roughly 20 cells migrated. That means the HBTs, the MOS transistors, capacitors, resistors, and even the searing. So the searing is the outer shape of your final device. And we generated the required Pi cell API classes. And the implementation is currently still in progress, so we have some examples ready, and for some specific cells you need some specific commands, and they are in development, and as I said already, in future it will be released in GitHub. That's very short slide regarding the teaching itself. We are just right now started to develop digital certificated design courses. So for that, even you will hopefully hear in the next future more. And then finally, some words about the Silicon Proven IP course. At first, we have developed a standard cell library. We know that even this needs some improvements. But finally, what you need, you have to establish a type of IP core library. So that someone likes to develop maybe a microcontroller, he wants to just use an SPI core, for example, or if you have an LNA, is analog design, then maybe you need a band gap, and there should be a type of IP core libraries, so you can just use a band gap, integrate in your device, and you know it's verified, it will work. Yeah. And for that, we are offering free MPW shuttle runs for the open community, and the first run was in May. And in brackets, you can see T566. That is our internal number for the shuttle run. And this is free for designers and developers, and it is funded by the project, by this FMD QNC funding project. And currently, the tape outs were made via Europractice. First, ETH Zurich with the well-known Iguana or devices. Even Hochschule Rhein-Main or KIT or Uni Linz provided first designs. And you can find some designs on the mentioned link. And the next one is in November 24. Here's a more detailed overview, so you can even see the schedule for the next 2 years, and you can see the area which is available for each shuttle run. And please consider this project funds can be used exclusively to produce chip designs for non-economic activities. So it means for university, for research project, and so on. And currently we are developing a concept to provide a free or even low-cost MPW area, similar like Google SkyWater made. And at the bottom of the slide, you can see a type of approach, what we have currently. How does it work if you like to provide your design to our fab for the MPW shuttle run. Yeah, one thing about the free shuttle run. Currently, it is funded by the German ministry, and so we have some special restrictions. So it means the samples that were produced are IHP proprietary. You can rent the devices, so it means there will be a type of official procedure. Maybe you have to pay $20 or whatever, or even it's free, but there's official contract for renting the devices, yeah, or hiring, yeah, what you like to say, yeah. If you like to get more details, you can even check the link. As you can see, the hiring period might be several years, so that's the idea of what we have, and yeah, maybe it's even possible to have a type of permanent usage of only a few prototypes. Yeah, and one very important thing is export and custom regulations. Yeah, for your designs. And finally, the tiny tape-out approach, what we know from the Google SkyWater, will follow in the future. So maybe this means a type of shared area for a lower price, but this is still in development, and details will follow later. Maybe just check our project website from time to time if you are interested in that. Funding, current state, that is quite nice because the starting point was this large FMD QNC project, and now there's even an update which I'd like to give because there is an open source design initiative, and it's called DE-Sign. And you see there are at least 4 different projects with different topics. So the flow space, for example, is focusing on radiation hard library. Aging is very important. If you like to bring your device in the space, then you even have to provide, or you have to check your design that this will even work in 20 years. Yeah. Demico, this is a pure analog project. So for a 60 gigahertz design, SignHab is focusing on the SRAM generator currently, and even root of trust elements and so on. And the UCDC Pro is a design challenge. It means really design challenge, for example, for students on secure designs. Some advertisements that I like to give. As I said multiple times, we have a BiCMOS technology with the HBTs roughly 350 gigahertz for FT. And this means we have very, very fast bipolar transistors. Use a chance, you can use, for that to make analog designs, you can create amplifiers, you can create LNAs or whatever, or to have some analog devices for 5G or 6G applications. Yeah, that's quite nice, and this is a big advantage and a big difference to the Google SkyWater. With Google SkyWater, you have only CMOS technology. Yeah, because I'd like to do this because currently I see that most of the people are using the CMOS part only. I can understand from design point of view because doing the CMOS designs, especially in digital, is much easier than doing the analog stuff, but we even like to push this. Yeah. And I like to close the talk with 3 wishes. The first one is use the PDK and provide us some feedback. The second wish is contribute to the PDK. If you have some idea and you see you have restricted resources because you are one single person and you're not able to drive such a quite large project, just contact us and we can get in contact with each other. Maybe we can find a funded project or whatever. Just type us and we will see what we can do. And third wish, even the project lives of this, please contribute to the tools. Yeah. Without the tools, you cannot do the designs. Yeah. Short conclusion, PDK development is ongoing. We are on coordination of the tool improvement to enable the basic flow. We are developing a digital design course, and we are supporting the IP core development because we are offering a free MPW shuttle run, and so finally silicon proven IP cores can be offered. Yeah, and further development in different direction will be done. So you have seen the 4 different projects or funded projects. Last but not least, this acknowledgement, thanks to the community, to all the people which are contributed to our project in the last 2 years and the different funding projects. And even finally, I want to say thanks to TSRI for sponsoring myself and the traveling costs in that case. Okay, then thank you very much. And now I'm open for questions.
Okay. Any questions? I guess there is a person from PowerChip. Do you want to talk about it? No. Okay. Oh, yeah, one thing. Oh, sorry.
First, thanks a lot for the interesting presentation. You mentioned something in the beginning. You said if you have a shuttle run or something and there is some space on the corners, you're sometimes squeezing designs in for free. Did I misunderstood, or that's really what you're doing sometimes? So in other words, if I have some kind of design and I bring it to you guys, and you cannot guarantee, but maybe you have free space and you squeeze it on the outside.
On the outside?
Of your wafer. Or is it always a real design you need to submit and then it will be placed?
Can you tell me the slides that I...
Sorry, that was somewhere in the beginning, but I forgot
the beginning?
slide. Yeah, you just mentioned it on. Yeah, the next one. Yeah, here. It was not on the slide. You just mentioned it when talking. Sorry. Okay.
If you have a design for the MPW shuttle run, even for the free,
yeah,
there are some certain conditions to put it on the free MPW shuttle run. Yeah. We will have a type of coming in check. So we have to check that your design is DRC clean, that you provide a type of documentation. And then we will have finally a type, if there are too many designs, we have to decide, okay, we have taking this design or we taking this design, depending on what is provided and what might be the quality of the design. Yeah, that might be the concept for the future.
Okay, got it. And then, sorry, I would have one more question. You said, sorry, you said you will provide some digital course for learning this or for doing it. So this course will also teach how to use the tools and everything, I assume. And what is your concept? Will it be I need to register with your website to get the course, or you will put it on GitHub?
I think the final idea is to provide this free. I don't know the technical details at the moment. I know that there's something in development, and I'm pretty sure it will be available for free for everyone, because that's even the idea of the funding project. Yeah.
Okay, cool. Thank you.
You're welcome.
Any more questions? Anyone?
So you mentioned Tiny Table, and so I'm just curious about the status between the IHP and Tiny Table. Is there any official timeline about where the real open for everyone Tiny Table will begin, like in the Q4 or Q3?
It's open for everyone.
It's open for, yeah, but I mean the registration. I mean, because as far as I know that it is still in a kind of closed beta test. So is it will it be like the the eFabless kind of their style of putting up a register front page and you can just click and
No, this is currently not. We are still in developing of this. If you like to contribute, please take a look on the website, and even you can contact us there. I mean, website, the GitHub website. Yeah.
I see. Thanks.
Yeah.